the Chapter 4 review. Section 4.1 has to do with classifying your triangles. Triangles can be classified by angles and by sides. An acute triangle is a triangle that has three acute angles, or three angles that are less than 90 degrees. An obtuse triangle is a triangle that has one angle that is larger than 90 degrees. This one is bigger than 90. If you put a piece of paper up here, you would see that the line goes outside the corner. Then you have a right triangle that has one right angle in it, and the other two would be acute angles. And then you have an equal angular triangle, which means that all three angles are congruent. And we learned later on in the chapter that that means that all three angles are 60 degrees. You can also classify a triangle by its sides. If you have a triangle that none of the sides have a congruency mark on it, so no sides are congruent, it's called a scalene triangle. If you have a triangle that has two sides that are congruent, so let's say I have a congruency thing on that and a congruency thing on that, then those two sides are going to be congruent, but the third side would not be. An equilateral triangle is a triangle that all three sides are congruent. These two things always go together. If it's an equal angular triangle, then it has to be an equilateral triangle. And if it's an equilateral triangle, it's got to be an equal angular triangle. You're going to use the information in this section to be able to solve for an unknown. So for this particular problem, it says find x, find jm, find mn, and find jn. And then it tells you that this jmn is an isosceles triangle with jm congruent to mn. And we know that jm is 2x minus 5. We know that mn is 3x minus 9. And we know that jn is x minus 2. Well, if it's an isosceles triangle and I have those two sides as marked, then all I have to do to solve for x is to set those two sides equal to each other. So I'm going to subtract the 3x and get a negative x. I'm going to add the 5 and get a negative 4. And then, of course, I would get rid of my negative, so I find out that x is equal to 4. Now, that's one thing I needed to find. But then it asked me to find each side. So I'm going to plug back in here. So I have 2 times 4, which is 8. 8 minus 5 is 3. So jm would be equal to 3. And then I have a 3 times 4, which is 12. 12 minus 9, also equal to 3, which makes sense because they're congruent. And then I have a 4 minus 2, so this side down here is equal to 2. Make sure you read the instructions as far as what they're asking you for. You also need to be able to classify them on a coordinate plane. This would require you to do the distance formula. So I need to find the distance between here and here, the distance between here and here, and the distance between here and here. So I would suggest you use the distance formula that you have programmed into your calculator. We're going to start with this side. So I have a negative 3, 2, and a negative 2, negative 3. And this side over here has a distance of approximately 5.1 when it's rounded. Then I'm going to do my next one. So between k and p, so I have a negative 3, a 2, a 2, and a 1. And this is also going to give me 5.1. So right now, those two sides are congruent. Let's check the third side. Negative 2, negative 3, 2, and 1. And that is a 5.7. So I would say that this is an isosceles, and I can look at it and know that it's acute. if they ask me to classify by both sides and angles, it's an isosceles acute triangle, or you could call it an acute isosceles triangle. So sometimes you can do them by both sides and angles. Sometimes they ask you to do it by sides. Sometimes they just ask you to do it by angles. Section 4.2 has to do with the angles of a triangle. There was a couple theorems that we learned. The sum of the interior angles of a triangle are 180 degrees. So basically it says if this is angle 1, angle 2, and angle 3, if I add the measurement of those three angles together, it's always going to equal 180 degrees. The exterior angle theorem, the measure of the exterior angle is equal to the sum of the two remote interior angles. So angle 4 is equal to angle 1 plus angle 2. Remember, it's not this angle, it's the ones that don't touch angle 4. So 1 plus 2. You could also figure 4 by the fact that this is a linear pair. So a lot of times it can be done both ways, but let's say this is 30 degrees and this is 100 degrees. Then I would know 30 plus 100 is equal to 130. So angle 4 would be equal to 130, and then you could quickly say, oh, well, this one's equal to 50. Most of those can be done by an exterior angle or by looking at the sum of the triangle angles equal 180. All right, so here's an example of one done like that. You're just going to work your way through. So I have angle 1, which I could get by adding 68 plus 36. So those are the remote interior angles of angle 1. So I find out that angle 1 is equal to 104. You could also find out what that angle is and know that the two of those together would equal 180. So I also know that if that's 36, this is 36, and I can look at that these three form a straight line, so I can figure out what 4 is by taking 180 minus 70 minus 65, and that's going to give me 4 is 45. Then I can turn around and go, these three also equal 180 because they are a straight line. So I have 180 minus 70 minus 45. And so this angle right here is 65. I would need to recognize that this plus this plus this equals 180. So 180 minus 36 minus 65 is going to give me a 79 up here. Then I'm going to come over here. I can figure out this angle because this forms a straight line. So I have 180 minus 118. So this is 62. So then these three should equal 180. So I have 180 minus 45 minus 62. So angle 5 is a 73. I can figure out this one because I can find this one right. Well, actually that's an exterior angle. These two are the remote interior angles, so I could just add those two together. 65 plus 82 is going to give me 147. You could have also figured out what that angle is and then figured out that that was a linear pair. So you'll have problems that have to do with those things that you'll have to apply what you know about the angles of a triangle. All right, section 4.3 has to do with congruent triangles. Two triangles are congruent only if their corresponding spots and parts are congruent. So if I have this triangle, A, B, C, and D, E, F, and I have that congruency statement, I know that angle 1 is congruent to angle D because they're both first. So angle A, is congruent to angle D. I also know that angle B is congruent to angle E because they're the second one in. Angle B is congruent to angle E. And then I know, of course, that angle C would be congruent to angle F. You can also make statements about the sides. So between the 1 and the 2 arcs, which is AB, is going to be congruent between the 1 and the 2 arcs, which is DE. Between the 2 and the 3 arcs, which is BC, is congruent to between the 2 and the 3 arcs, which is EF. And then between the A and the C, which is the 1 and the 3 arcs, is congruent to the 1 and the 3 arcs on the other one, which is DF. So those are the 6 statements that you can make based on the fact that those 2 triangles are congruent. We also talked in this particular section about transformations. We talked about a reflection, which means you would take a object like a triangle and you literally would flip it over. You know, my drawing is limited here, so you could flip it over the reflection line. A translation is you take the triangle, you don't rotate it, but you might move it 2 to the right and 3 up, so then all of a sudden you've got that same triangle that has just slid over there. Rotation means you're going to turn the triangle, so the direction is going to change. So that would be like a representation of a rotation. This thing has rotated around. This you just slid over and you slid up. So this is a reflection, this is a translation, and this is a rotation. You got to be able to recognize those. Then we talked about shortcuts for proving that triangles were congruent. We talked about SSS and SAS. SSS, if I was going to prove these triangles were congruent, I would have to prove that every side has a congruent side on the other triangle. So that would show you SSS. SAS says that the side, the angle that's included, and the other side, on the other side of the angle, has a congruency on the other triangle. So I would go, okay, that side and that side are congruent. That angle and that angle are congruent. And that side are congruent. That would be enough to prove that these 2 are congruent by side, angle, side. Remember, on this one, the angle has to be inside the two sides. So in other words, you'd have to be able to go in order: side, angle, side. You need to be able to use this information to do a proof. So here's a proof that's listed out. I have RS is congruent to UT, and I have RT is congruent to US. Okay, so let me start the proof here. You know that you're going to write your given. And the reason is given. Notice, I already have 2 sides. Okay, so if you will, this is side 1, this is side 2. In order to prove that these 2 triangles are congruent, all I need is the third side. They have the third side in common, so my second step is TS is congruent to TS, and that is by reflexive property. So that's your third side. So I have everything listed to be able to prove that these 2 triangles are congruent by side, side, side. So that's step 3. And that completes your proof. You prove those 2 triangles are congruent by side, side, side. Then our next section had to do with angle, side, angle, and angle, angle, side. So on this one, to be able to prove 2 triangles are congruent, you have an angle, a side in the middle, and then an angle on the other side. So if you will, you have angle, side, angle, exactly in that order. This one, so this is proved by angle, side, angle. This one you have 2 angles in a row. and then the side after them. So it could have been that side or it could have been that side. But this is angle, angle, side. Okay? These help drive your proof. So you're going to turn around and do a proof on that particular thing. So again, write your given down. So S is the midpoint of QT. And QR is parallel to TU. Now, if you see that parallel thing, you should automatically be thinking like alternate interior angles, corresponding angles. Most of the time, it's alternate interior angles. So let's use what they've given me in the given to drive my train here. So I have S as the midpoint of QT. So being the midpoint means it cuts those that big segment into two smaller segments that are congruent. So I can say QS is congruent to TS, and that is definition of midpoint. And I would encourage you to go ahead and then mark the congruency on your illustration then. Then I can also say if these are parallel, then what I have is I have two sets of alternate interior angles. So I can say angle R is congruent to angle U. So that angle and that angle are alternate interior angles. And I can say angle Q is congruent to angle T. Those are alternate interior angles because here's your two parallel lines. This is a transversal and this is a transversal. So the reason is alternate interior angles of parallel lines cut by a transversal are congruent. Okay, so now if I go back and look at this, I've got enough to prove that these two triangles are congruent. Okay, so I have side, angle, angle, or if you will, angle, angle, side, which is angle, angle, side. Okay, angle, 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 side, angle, angle, side. So I proved it by AAS. Section 4.6, you have isosceles triangles. If two sides of a triangle are congruent, then the angles opposite those sides are congruent. So let's say I have angle A, B, and C, and then I know that this is an isosceles triangle. I can automatically assume if those two sides are congruent, then these two angles are congruent. Angles opposite congruent sides are congruent. This angle is opposite that side. This angle is opposite that side. So I know that those two angles, angle A and C, would be congruent. So on an isosceles triangle, your two base angles are always congruent. In the contrast of that, or the opposite of that, if two angles of a triangle, if angle A and angle C are congruent, then the sides opposite those angles are congruent. So if I know those two angles are congruent, I can automatically assume that that side, which is opposite C, is congruent to that side, which is opposite A. Then, and we've already talked about this, if you have an equal angular or an equilateral, each angle would have to be 60 degrees because remember they have to add up to 180. And you'd have to use this information in proofs and in solving for an unknown. So let's say they give me this triangle. They tell me that this angle is congruent to that angle. Well, then I know that this side, which is opposite the t, is congruent to this side, which is opposite the s, and all I would have to do is put those two equations together. So I have 2t plus 6 is equal to 3x minus 6. I'm going to subtract the 3x, so I get a negative x. I'm going to subtract the 6, so I get a negative 12. So I find that x is equal to 12. Obviously, if they wanted me to solve for the side, st, I would plug it back in. So I would have 24 plus 6, which is 30. So this side would be 30. This side would be 36 minus 6, which is, of course, also 30, because I know that those two sides are congruent. Then you might want to use this in a proof. So we have this illustration over here. I have angle 1 is congruent to angle 2, and that is your given. So I'm going to go, this angle is congruent to that angle. I'm trying to prove that AB is congruent to CB. So that's what I'm trying to prove. Notice, if this angle is 2, it would be congruent to 3. So angle 2 is congruent to angle 3 because vertical angles are congruent. And then by transitive property, I can say angle 1 is congruent to angle 3. Oops, I got my numbering wrong here. Okay, 1, 2, 3. So this is by transitive property, because if 1 is congruent to 2 and 2 is congruent to 3, then 1 is congruent to 3. So therefore, I also have a mark right there. Therefore, AB, which is the side opposite 3, would have to be congruent to BC, which is the side opposite 1, because sides opposite congruent angles are congruent. So therefore, you've proved that that side is congruent to that side because this is opposite that, this is opposite that. Section 4.7 has to do with triangles and coordinate planes. One of the things that you have to do is you have to be able to position and label a triangle. So for instance, position and label, this should be an isosceles triangle DGJ with a hypotenuse DJ and the legs 2A units long. So I'm just going to take this and I'm going to make this the hypotenuse. So this would be DJ, and then this would be G. And I can say that the ordered pair at G is 0, 0. I can say the ordered pair here, which is 2A units, which is also 2A units here. So J would be 2A 0 because I go over 2A units and I don't go up. D would be 0 to A because I don't go over at all, but I go up 2A units. So that would be one way to position an isosceles triangle DGJ with a hypotenuse DJ and the legs 2A units long. The other thing you do here is you can find the missing coordinates of something that they've already drawn for you. You can see that this is an isosceles triangle, so therefore this measurement and this measurement are going to be the same. So if I've gone over negative 3A units here, I go up positive 3A units and up 0 here. This would be, I'm going to go over 0, and I literally have no idea the height here, so I can just call it C. It's going to be another variable. Okay, so that's a quick rundown of the chapter. Your homework for this is page 228 through 230. 9 through 14 all, and then 16 through 28 even.